Hello and welcome to everybody on Cloud Fitness. So in today's video, we are going to see how we can create Inference Profile Lakehouse Monitor using the API. So I do recommend watching my previous videos on Lakehouse monitoring in order to understand Lakehouse monitoring end to end. If you directly jump onto this video, then it will be a little difficult for you to understand because in the previous three videos, I have given a very detailed explanation on the Lakehouse monitoring and the different profiles and how to create Lakehouse monitor using different profiles. So let's move ahead. But before moving ahead, I do recommend all of you guys to connect with me on LinkedIn as well as on Instagram, and I will leave the link in the description box. So let's move ahead. So when I talk about creating inference profile, right? Inference Profile Lakehouse Monitor using API, this is specific to the model performance. Whenever you want to understand how your model is behaving over a period of time, that is when you are going to use it. In the previous three videos, they were more focused on the data engineering aspect. Whenever you had to understand how your data is performing over a period of time or with respect to a specific snapshot, that is when we have used the snapshot profile as well as the time series profile. But this one is specifically for the model. Now, I have shown this diagram earlier as well. So if you look at this, we were till now we were actually working on this data pipeline monitoring the statistical property of these data pipelines, but now we are going to check how to do that for an ML pipeline. So you can see that this is the feature table, right, that is used as an input to the model. Now you create a model, you use feature table as an input to the model, and you make predictions, right, and that predictions is actually stored in your inference table. And similarly, then what happens? Your model runs maybe every week, every day, every month, depending upon what the requirement is. It will run multiple times, right? Now, what will happen is every time the model runs, you are sending new data, right? You are sending new data to the model for making predictions every time it runs, and then the prediction is actually stored in the inference table. Now, in the same table, you can also store ground truth. So, ground truth is something like, for example, let's say you have made a prediction on how likely is it for a customer to purchase a particular product, right? Now, you have the details of the customer, you have given it to the model, and the model is predicting that okay, this guy is, there is a 70% likeliness that this guy is going to purchase the product, right? But he has not purchased or rejected the product yet, so this is just a prediction. So you store the prediction over here, but now a month later or a 2 month later, you know whether the person has actually purchased the product or not. That is called as your ground truth. So you can store your ground truth as well in the same table itself. And here what we can do is we can monitor the performance of the model using this inference table itself. You can monitor the model quality, right, using the metrics of the inference table itself, and you can understand how but using different metrics of your particular model, you can actually understand the drift that has happened on the inference table itself. And this is what we are going to do today as well. So let's move ahead and see exactly how do we do that. So now in this particular problem, what we are going to do is we have classification problem over here, right? Classifying yes or no, that is a kind of a classification problem. So in case you guys have not watched my playlist on the machine learning, I do recommend watching that because this will help you to give a very basic and a good idea on how machine learning works or how data science in general works. So here we are having a classification problem. The model is solving a classification problem. So the very first thing is that we are going to do is we are just going to install Lakehouse monitoring client, right? So we are going to install the library over here in form of a wheel file that we have been doing for all our problems. So you need Lakehouse monitoring library installed, right? And if you look at this, we are going to use this particular catalog. So we are going to use this catalog and the schema because we have already discussed in our previous videos that monitoring, Lakehouse monitoring needs Unity catalog, So it is mandatory to enable Unity Catalog on your workspace. And in case you guys have not watched my UC videos, I do recommend watching that as well. Now, this is installed, so let me just restart the kernel. After that, I am specifying here that this is the catalog I want to use and this is the schema I want to use throughout. Okay, and make sure you guys have privileges on the same as well. Um, and after that, these are basically the parameters that I'm putting in over here. So you can see unique suffix. So this is just a suffix that I'm putting to my tables, BB, Bhavna Bedi. And then the table name, right? So my table name would be, because my table is stored in a catalog and schema, this is the catalog and this is the schema, and then my table name is this, right? And then I'm adding a suffix to it named as BB. Similarly, I have a baseline table. Now we have already discussed in the previous videos that lakehouse monitoring needs a baseline table. Now it's not mandatory to have a baseline table, but in this case we will use baseline table. You may choose not to use it as well, so that's completely fine. So we have created the placeholders for the table name, for the baseline table, and then the model name. So you have to create, because here we are trying to check the model performance, right? How the model performance has been changing. So we will use the model, so that's why we will put the model name over here. So this is our model name with the unique suffix and then the timestamp column. So now remember that whenever you guys are running the model, right, you are not going to run it for one time. You are going to run it multiple times. So you will always have a timestamp associated to a prediction. So if I am a customer of any XYZ company and they are running some model on my data, right? So they will not run it one time. They will run it multiple times, right? So I might not have bought a particular product right now, but they might want to understand when would I buy the product. Maybe they will run the model again after 2 months, maybe again after 3 months to check the likeliness of my purchase for a particular product. So that is why whenever a model runs, you will always have a timestamp column. I'm trying to, explain little basics as well, because if you are coming from the data engineering background, then you might have little difficulty in understanding these terms. So after that, you have something called as model ID column. So whenever you have a model, right? Now, whenever you are training a model, okay, so the result of the model changes. You are training the model with newer and newer version of the data, and that is when your model version also changes. So that is why this model ID column is used, so that you can uniquely identify your model. And then you have a prediction column, right? But basically, it's related to the prediction that your model is making. So for example, I am saying that I want to predict the likeliness of me buying a particular product, right? So what is the prediction column that we are going to use for it? Now similarly, you have a label column. Now what is this label column? Label is like okay, this is coming from the ground truth that I explained earlier. Label column is nothing but when, okay, right now I'm checking the likeliness of me buying a product. But after 2 months, we will have the data whether I bought a product or not, right? So that is nothing but a label column which is checked that okay, this person has bought the product or not, and you can compare it with the model output. Now once you compare it with the model output, you will understand the accuracy of your model, right? And then there's an ID column, right? It is this is little, I will explain this later on, ID column. Now I'm just checking if okay, let me run this. In fact, I did not run it while explaining. Okay, so this is nothing but we are just trying to drop the tables if they already exist. However, they don't exist yet. Okay, and then again, so in case the model is present in the MLflow client, then in that case we just have this function to clear the model. Otherwise, you don't need it. If you're running it for the first time, it's fine. You can ignore this as well. And then now the very first thing is creation of the data set, right? For everything I need a data set, right? So I'm using Databricks data set, open data set that we have. I'm reading the file adult.data. This is one of the files that I have used in other videos as well that I have created, and I'm adding a new ID column which is nothing but a UUID. This is kind of a primary key, you can say, column which is uniquely identifying each and every row over here at the moment. And this is, let me run this and we will see how our data looks like. right? We have already defined the schema as well at the top. We are going to use this data in this whole lecture or the video. So now you can see the output of the display. So you have age, work class, education, education number, and different columns over here, and the ID column and the income of a particular customer, right? Or a income of a particular candidate. So if you look over here, this is the income column, and we are going to use it for the prediction as well. So now you have this data set, and I hope you guys have seen the data set. How does it look like? And some is double, few columns are double data type, few columns are string data type. Now in the next cell, I'm just cleaning the data, so there is nothing major that we are doing over here. So you can, the main thing over here is to understand the concept. So you can see here there are question marks, right? So we need to replace these question marks. So you can actually see we are replacing all the question marks with a null or none value. So over here, right? So like this, we are just trying to capture any wrong data set, and we are trying to replace the value. So you can see there are multiple question marks in the data set, right? And after this is done, we are trying to split the data. So when I say split the data, now we have a data set. Now we need the data to train the model. We need the data to create a baseline table. So I told you, right, that we have a baseline table which is called as the standard data or the correct data against which we can compare the model. So that is also against which we can compare the model output. So that baseline data set also we need. Inference data, that is also something that we need. So what we are trying to do here is we are going to split everything. Train data. So from one data set itself, we are just trying to get the data. For training, we are keeping 60% of the data. And for baseline table, we are keeping 20% of the data. For the inference data frame, we are again keeping 20% of the data. So in case you guys are not from the model, AI background, then in that case, let me explain you. Inference data set is nothing but the data set that will be an input to the model for making predictions. So I have trained my model. So first I train my model on a particular data set. Now my model is ready. Then I send my actual data to the model, which is nothing but my inference data set. And this inference data set is further used to make predictions. Like you make predictions on top of this inference data set. So we have got all of this. Let me just run this as well. So now you can see that I have all of this ready, right? So my train data frame, baseline data set, as well as my inference. So once I have this, now I need to train the model. So now I'll not go into the details of the machine learning over here because that is not the objective. I'll simply run the sklearn libraries that we have imported over here. So most of these things I have explained even in my machine learning playlist as well. So right now we don't have a model. Otherwise, this function as we have run at the top will just clear the model if you already have it. And then now you can see I have three data sets: train, baseline, and inference. So here what I'm trying to do, here from the train data set, I'm trying to define my training data set, how my training data set should look like, right? So let me just run this command. This is nothing but this is how my training data set would look like over here. Now this training data set will go into the model and it is going to train the model. After this, again, this is more related to the ML part. So categorical columns, numerical columns. Categorical are more like your string type of columns, which helps to segregate things in terms of categories like yes or no. Then you have numerical, and then this is the pipeline on how this is specific to the Databricks. When you run a model in Databricks, you have to, kind of go through this pipeline step. I have explained this already in my previous videos as well. And then we are running just random forest classifier, and we are giving all the parameters over here. And after this, we are just trying to run the model over here. So let me on the training data set. So this is the training data set that we have created at the top, right? So we are using that training data set to train our model, right? So if you look at this, we have X train and the Y train, and this is the training data set that we have created already, right? We have created this training data set already. So now my model is trained already, and it is registered in the ML flow as well. Now my model is trained. Okay, I have a model ready now. It is trained. Now I have where is my baseline table? So here I'm going to create my baseline table, which will show me the standard set of values that are expected. Basically, it's a good data that we assume. So we will give some references. So for example, we know that this person is likely to purchase a particular product. This person is 90% has 90% likeliness. The other person has 50% likeliness, and that is kind of the baseline. So that is a better data, or you can say most accurate data that we would expect our model to. We don't want our model to drift more from that baseline. So that is what we are trying to create right now, the baseline table. Now after this, here we are just defining the features and the model path that is registered in MLflow. And here you can see we have the baseline data frame. So here we are creating the baseline data frame over here, where we are adding two new values. Okay, so understand here in the baseline table, we are adding two new columns. One is the prediction column and the other is the model ID column. So model will run on, so a model will have an ID which is unique for that particular model, and it will make a prediction, right? So the baseline table should have a prediction already, because we are giving the correct set of data as the baseline table, that okay, for so and so person, this is the prediction output that we have, and this prediction output is supposed to be the best prediction, the best possible prediction. So you need to give the prediction column, and you also need to give the model ID. So that is what is done over here. And we're just going to display the baseline data frame as well. And after this, if you can see in this command, in the next command, we are just writing the, okay, let me just show you the data first here. So this is the data set, and you can see here the prediction, right? I told you that we are going to do prediction on income. So here is the model ID. Sorry, here is the model ID, and this is the UUID that we have created at the top. So now you can see that this is the input data set, right? And this is the prediction, and this is the model ID. So this is the baseline table. We are saying that this is the baseline table. Now we are writing, now we have to write the baseline table, right? So while writing the, let me just run this command. So we this data frame, we are creating a table. We have to create a baseline table, right? Now here we have enabled change data feed as well on this particular table. So in my previous videos, I have already told you that you should have change data feed enabled on these tables, because it will help to get the data from the metrics tables really fast. So try to always enable change data feed. So if you do not enable, usually Databricks will always give you a kind of a warning that you should have it enabled. So this table is already written. Let me just refresh my catalog explorer as well over here, where you can see that you have this baseline table. So adult census baseline underscore BB. So we have created our baseline table. We have created our model as well. So the model is ready. Baseline table is also ready. Now what we have to do? We have to generate the predictions. Now we have to run the model, right? Now we have to run the model. Now to run the model, right, what we have done at the top, we have created inference data frame as well. So if I go at the top over here, you guys can see that we have created an inference data frame. Now I told you what this inference data frame is used for. It will be, the data will be pushed to the model, and model has to do the prediction. Now if I click on this inference data frame, right, this is the data frame that we will pass to the model. So now if I go down over here to the, okay, so now since we have to train the model, what we are going to do? So we have segregated it into two data frames right now. Okay, so if you look at scoring DF1 and scoring DF2, so we have split it into two batches right now. Okay, and also remember that the inference data frame that we have created, we are dropping the label column. So this label column is what? This label column is nothing but it is the column that is a prediction. So for example, if I go at the top, let me show you the label column that we have added. So if you look at this, label column is the income column, right? So the label column is nothing but the income column. So now if I'm saying, let me go to that particular cell. This is my inference data frame. So I have to remove income column from here because income column is what I have to predict. So I cannot give to my model what is already there. My model has to predict the income. So this is the prediction column, right? So that is what is called as a label column. So I'm clarifying the terminology is also over here. So this is what the model has to predict. So I have to drop the income column from here. So that is what is happening over here. Yeah, so we have dropped the label column and we have got two data frames, scoring df1 and scoring df2, right? Now here uh, we will come to this as well, but if you look over here, here I am also adding one new column called as timestamp column to the data frame inference data to my inference data frame, which is nothing but now this timestamp column is what. So when you're passing the data to the model, it has to have a timestamp, right? It has to have some particular date because you are going to run a particular record on the model on a specific time period. So that is why we have to add over here a timestamp column. Now in this timestamp column, you can see we have used time delta, which is nothing but it is going to extend the date. So if the date is 18th today, so the data will have the date of 19th. So this is where we have added the timestamp column, and after that we have added the prediction column, like what is the column that it needs to predict, right? And after that you can see, okay, let me run this as well. Okay, let me run this particular command. We did not run the previous cell. Now let me run this cell. After this, you can see that this is the data frame which the model needs to predict. We have model ID. We are giving the model ID as well. Okay, to this particular data frame, we need to give the label column, which is nothing but the value will not be there, but it is a label column which model needs to predict, and we are writing this table, and we are writing this table into the catalog, and this table has to be there because the model will actually put the result into this particular table itself. That is what is assumption. So the model will run on this predict data frame, and it is going to write the output to what, to the final table, which we also called as an inference table, right? And on top of the inference table we are going to create the monitor. So here what we are doing, we are creating the inference table. So let me just run it, then maybe you'll understand. So what has happened here, we are creating the inference table right now. Okay, we are writing the data into the inference table, and we are saying that this is the model output that a model has. So now you can see that this has run. So what will happen? Now this table will get created. Now if I go to Catalog Explorer, you have this table, Adult Census Inference Log. Now if I click on this, now what is this? This is the table where model will give the output, right? And what we have done, we have already added the data to it. Okay, this is how the model output will also look like, right? Now you can see at the end, you have a prediction column. So your model has predicted this as the income. Okay, and what is the actual income? This is the actual income which you don't have right now, because when you are running this model, you don't know what a customer is going to do or how much income a customer has. You will get to know, this is the ground truth. This truth you will know maybe after 1 month, 2 months, or a year. You don't know that, right? So this is your inference table, and on top of this inference table we are going to create the monitor. Okay, so now the inference table is created. Let us create the monitor. Now for creation of the monitor, in my past videos as well, I have shown you that we have to import lakehouse monitoring, and in case you need any help on creating the monitor, you can run this. This is going to give you a documentation on the whole lakehouse monitoring, how to create a monitor and all, so it will be really helpful to you. So now, specific to understanding the drift in the model, you have to mention few parameters over here. Problem type, what kind of problem you are solving, classification or regression. So here it's classification. So if you want to understand the difference between classification and regression, I again will direct you back to my ML series. Now the granularity, how you want to compare. using which window size. So if I have something today and if I have something tomorrow, then you are comparing it between today and tomorrow. So you have the granularity of one day. Slicing expression. So when I see the data into my lakehouse monitoring dashboard, what are the slicing expressions? How I want to filter the data and see it. So these are the slicing expressions. So let me just run this as well. Now after this is done, we have to create the monitor. So lm.create monitor, this is the same across, whether you are doing snapshot, whether you are doing any other time series or even inference. So in all these, you have to use lm.create monitor API. After that, this is the table on which you have to create. Then the profile type, right? So this is your inference, because you are using inference over here. And then the timestamp column, you have to give the timestamp column, granularity, model ID, prediction column, problem type, which we have already defined at the top, that that it is a classification problem. And then the label column. Label column is something that the model has to predict. Now similarly, you have a baseline table. You have to define which is my baseline table, slicing expression, and the output schema where my table. So right now, this is the schema where what we have defined, where our tables will lie. Which tables? Profile tables, right? Profile and the drift table is going to lie over here. So now let me run this. So this is where your monitor gets created, but the monitor is created, it's just created, so it has to be active, and as well as we need to refresh the monitor in order to see it, because the tables will be created only when it runs. So you have to kind of run the monitor, you have to trigger the monitor. To trigger the monitor, I'm going to run this command, and this usually take around 5 to 7 minutes to run. So I would pause in between until this gets created over here. So now we see that the monitor has successfully refreshed, and you can see that it took around 8 minutes. So now if I go to catalog, let me just refresh to the catalog. Now you can see that you have two tables present here, drift metrics and the profile metrics. Now your profile metrics, what it will have? It will have your inference log profile metrics, and if you have set the baseline, then it will have the baseline profile metrics as well. So now if I go to and check the sample data, then in that case you will see how it is capturing. So you can see the window, right? It is taking the window of one day that we have specified. So the input type is log type, here is input, right? Now what is this input? It is the nothing but your inference log. That is what inference table, that is what your input is. And now you can see granularity, slice key, slice value, and how it is calculating average, quantiles, number of zeros, max length, average length, the number of null columns, percentage null, recall, percentage distinct. So all these statistical property, it is already capturing in the profile metrics. Now if you click on the drift metrics table over here, right? So now if you look at this, now it is going to tell you the drift, right? If you look at the window again, the window is one day. For each you can see the column name over here, it's table and the column name. So if the metric is calculated at the table level, it will be table here, otherwise it will be the column names. So now if you look at this, right, so drift type, how it is calculating the drift? It is calculating the drift from the baseline table, count of delta, right? So now it is trying to tell you what is the difference, what is the delta for each and every row, as well as at the table level. For the table level metrics, it is going to show you table level details. For the column level, it is going to show you column level uh, drifts. So now, and at the same time, if you want to check the monitor, right, if you monitor is nothing but the dashboard eventually, right? So if you click on the dashboard over here, you can see that how your metrics or how the drift is happening in your model, right? So this is exactly how you can see the warehouse is starting. So it might take a bit. So but if you see the slice value, so whatever slice values we have given, okay, over here, so if I go at the top, we have given set of slice values. So these are the slice expressions: age greater than 20, 25, 60, and all that. You can see that you will be able to slice the data over here. You will check the granularity, slice key, and for a particular model ID, you can see the different metrics over here. So performance metrics, so what is the accuracy score, recall, F1 score, precision. So all this you can see over here. And how does it change over the time? Because you can filter on the time. So you can see top predicted class, null, F1 score. So all these details related to your metrics, how you want to compare, right? If you want to compare it based on a baseline or a previous window, what kind of metrics you want to check, all these you can go over here. So distribution over a time, prediction, model performance. If you want to check any model, let's say we want to check F1 score, right? So the details related to that, you can actually go ahead and check different metrics for your model. Even the confusion metrics also you can see over here for your model. So details like what is precision, recall, confusion metrics, I have already put that in my machine learning playlist, so you guys can watch that in case you are interested, if you are coming from the data engineering background and have interest in the ML side as well. So data integrity parts, and likewise you can see multiple drift patterns over here, even the categorical data profiles, right? So if you can see over here, the work class, based on the work class, what is the count that you have in your data set, what is the percentage of null, and how for each and every column. So you can go ahead and check all of these once you do the same on your laptop as well. So fairness, biasness of your model, all these things can be seen over here, right? And this is nothing but a very uh, a nice representation of how your data is drifting. Also, this is what we have done until now, but now just to show you how does it change. So for example, um, let me create a drift. So for example, right now what it is doing, it is taking the data. If I go to the catalog explorer, it is taking the data from your inference log, from your baseline, right? And it is comparing. Baseline is supposed to be the best data. Now in the inference log, if we add another set of data which is not very good data, let's do that. So ideally the model will do that, right? But right now we are ourselves adding the data into this table. So now we have just taken, okay, let me run this at the top. We have not run the previous command. So we are taking the data from the profile table right now. After taking the data from the profile table, okay, so this is not needed. So this is what we have seen in the on the board as well, on the dashboard as well. So we have already seen fairness and biasness, that you can see it over here. Okay, so what we will do, we will try to add the data into the inference log table. Okay, now to do that, you can see we have created scoring df2 as well. We created scoring df1, we created scoring df2. Now in this scoring df2, I am creating a new column called as work class, right? And wherever the work class is null, we are adding a new work class, right? Otherwise, if we will keep it as the same work class. Similarly, we are adding a new column as sex, where it is hard coded as female, right? Similarly, we are adding a new column hours per week, and we are specifying the value with 95 over here, right? So what is happening over here, we are just creating a data set which we are going to load into the uh, inference table over here. So the model is getting the new data, and it has predicted something over here, right? So now in this case, what we are doing now, if you look at this, here I'm adding the timestamp as well, because we need to add timestamp to the data as well, right? So in this timestamp, you can see I have the scoring df2 which we have created at the top, and we have the timestamp column, prediction column, model ID, and it's a delta table, and we are just appending the data over here, right? And we are saving it as the inference table. So we have just simulated the data over here, so you don't need to confuse too much on the transformation part. Transformation part does not matter. Here we are just simulating the data, and we are loading it into this inference log table. Now this inference log table is the output of the model. So your output has predicted some more details. That is what we are adding it over here. Now once we do that, what we can do after doing this, we are we after doing this, actually we can directly go ahead and refresh our refresh our monitor. Okay, we can simply go ahead, refresh our monitor. So what will happen is, now your now your inference table will have the data that we have recently added to it. It will have the data that we have recently added to it, and at the same time, when you refresh your dashboard, right? When you refresh your dashboard or when you refresh your dashboard on a schedule, which you can also do from here. So if you go to the inference table on which you have created the monitor, right? If you go to the quality tab, you can add a schedule, edit monitor configuration. Over you can uh, add in the advanced option, you can go, you can refresh it on a schedule, and when you refresh it you will see that difference as well all the time. You can add notifications over here, asset directory. In this particular location you will see the queries which are related to the dashboard. So if I click on any dashboard over here, if I click on these three dots, I can simply click on view query. So the moment I do that, this query is nothing but this is the query being used for that particular visual, and it is nothing but it is checking the profile metrics table. Most of these queries would be either checking profile metrics table or your baseline table or your drift metrics table. Now all the queries are stored at this particular location, and at the same time, if you want more slicing on any other column, you can add that. If you have a custom metric, right, you can add your custom metrics as well to this particular profile monitor. Now in this, once you do that, you can actually, you will see that if you have scheduled it at a particular time, it is automatically going to refresh. So right now you can see the last metric refresh was 11 minutes ago. So after adding the new data over here, and if you run it, it is again going to create it is going to refresh your dashboard. So this is all about the basics, but yeah, you can actually do a lot of things over here. This refresh is still running, but for example, uh, you have ground truth, right? So till now what has happened in this particular table, if I go to the inference log table over here, you can see the ground truth is null, so this income is null. You can add the ground truth as well, right? Right now it is null because when model is doing prediction, it does not know what the actuals will be. So actuals come later on. So you can once you update the value into the ground truth, then what will happen? Then in that case you can check the metrics, you can check the metrics of your model as well again. you know you can talk about, you can check the performance metrics uh, of your that particular model, because now you have the ground truth. You can compare what your model has predicted against your ground truth, and you can check various metrics and how your model has behaved over a period of time. So these things also you can do it. You can add custom metrics as well. Now custom metrics you can add again through the API. So if you can see, this is a custom metrics, aggregate type, what for example, if you see, this is the definition, right? So for example, expression over here, exponential for the log average that you have calculated over here. So similarly, you can create your own custom metrics both through the UI, what we have seen right now, as well as through the code, and you can refresh your dashboard all the time. So I hope you liked this particular video. You understood what it means and how it can be used for the models as well. I understand, this video has too much of details, but yeah, do remember, in case you have not understood it in one go, I do recommend watching the video again, maybe a little slow. It will really help you guys, because this video is a full packed video with a lot of content. In fact, most of my videos are like that, where I try to put in a lot of content in short amount of time, so that you guys can effectively use the videos, you can make effective use of your time as well. So thank you so much for being till here, but do remember to like, share and subscribe to my channel. Thank you so much for being till here.